Hello everyone. Today we will be solving question number 1324 of the lead code delete leaves with the given value. It is a binary tree question. So the question state given a binary tree root and the integer target value, delete all the leaf node with the value target. Note that once you delete a leaf node with the value target, if its parent node become a leaf node and it has the value target, it should also be deleted. You need to continue doing until you cannot. So the question state that we have given a binary tree like in this example 1 2 3 2 2 4. So we have given a target value. So we will remove all the leaf element which match the target value. Like in this example, for this current scenario, the target is this value, these two, or these two. Both are leaf element. So we will delete these values. So we deleted these values, we get this tree. Now we delete values. Now its parent element became the leaf node. So if it is leaf node and value equal to 2, then we also delete the value for the parent. Like we delete this 2. Now our answer is 134. And for every leaf node like 4, there are values not equals to the target. So we will return the root. In this example, we can see we have given target 3 and binary 13332. So first we delete these two leaf node that is parked like 3 and 3. After that, you can see our tree become 132. This parent is matched with the value target 3, but it is not a leaf element, so we will not delete it. In this example, in third example, you can see our tree is 1222. Our target value is 2. So this leaf element matched with the target value. So first we will delete this. Now again after deleting this value, the second leaf element is matched with the target value. We will delete it again. Now again our leaf element matched with the target value. So we will delete this. Then our answer is 1. So this is a value. Constraints given as the number of node in the tree is range in the 1 to 3000. Node dot value is 1 to 1000. Target is 1 to 1000. So how we will solve this problem? Like let's see for this example. Our approach will be we will apply depth first search. We will go into the depth of the left. Then we will go depth of the right. So what we will do? We go to the depth. If it is null, then we will means if value is null means for its left the value will be null, then we will return null. Otherwise, if its left value is null and right value is null means it is the leaf element and its value equal to target, then it's in this parents means its parents we will return null. Like the value for 2 means its parent, it is the left value, so node dot left equal to we go to the we will make DFS call for its left element. It is leaf element. So for leaf element, we will return null means we will delete this node. Then again, we will return this 2. The value is now null. So its left is null, right is null, and it is equal to target. So these two will also deleted and we will return to the one's left element. Then we make a right call. For right call, we go to the 3. For 3, we have two calls, left call, right call. So first we make the left call. For left call, its node means for left value is 0, for right value is also 0 and it matches with the target value. So we will return its parent null. Means we will return its node dot left equal to null. So its left element is null. Then we make a right call. We will return from the right call. So in this way, we will solve this. Like in this example, first we make for 1 we make For 1, we make a left call, go to the 3. For 3, we make a left call, go to the 3. 3 matches the target value. Then we will return its 3's parent, means 3, this 3 dot left equal to null. Then it we go to the right side, it is leaf value and it does not match with the target, then we will return to the 3. 3's work means 3's left and right both are processed, then we will return its parents 1. For its parents 1, uh, left call is completed, then we will make a right call. We go to the 3. 3 is a leaf element and its value is equal to the target value. Then we will return its parent null because we will delete this element and we will store node for one node dot right equal to null. After that we get this answer. So this is our approach how we will be solving the answer. Let's see the code. So the code is we have to return the root. So what we will do? We will make a DFS call. If our node is null, means our, you can say means root for every DFS call it is value will be updated. So root becomes node another like that. So if root is null means if we go to the leaf left and leaf right, then node root will be the null. So if root is null, then we will return null. Otherwise, we will make a DFS call for the left value and right value. So for left value, we will again make a DFS call, remove leaf dot left. We will pass left value is root dot left and target. So what we will do, like in this example for this case, for this two case, root dot left, go here. So if root dot left equal to null, means its value is equal to null, and right root dot right equal to null, and root dot value equal to target, then we will return null. So here it will return null because for the left value we will update the left root dot left means it is 2 dot left. We go to this node root dot left is null, right is null means this is leaf node, and value equal to the target value, then we will return null means root dot left became null, root dot right is already null. So for now again root dot left equal to null and root dot right equal to null. So its parent means we will return one null. So for one root dot left equal to null, so its all left values are deleted, and for right call its all right value we will delete it. So this is our solution. You can say we are visiting node only once, so complexity is big O of n because we are visiting every node only one time. We are not using any extra space, only recursion stack space is used. So big O of n is space complexity and term complexity of big O of n. Thank you. So let's submit it. So this is our solution.